Hi everybody. So today's lesson is about the full projectile motion. So this is done in two parts and this is mostly a problem solving lesson. So I'm going to do question 4 and I'll tell you how your thinking should be for these sort of questions. So here's the question. A soccer ball is kicked with an initial speed of 14 meters per second at an angle of 30 degrees to the ground. And then there's a whole lot of little part questions. And in the end, what you have to find is where does the soccer ball land after when it reaches the ground. So this is the only information you're given. The initial speed and the angle it makes with the horizontal. And what's going to happen is once the soccer ball is kicked, it's going to follow this whole parabolic path. Okay, and like I said, and our end thing is to get the range. Now, if you look at it, the range is actually the horizontal distance. So remember what I told you yesterday, we actually separate out the vertical and horizontal components. So I'm just going to draw that. So this is your vertical component and that's your horizontal component. So what do we have to find out? We have to find the horizontal distance traveled. We also need to find out, in order to find out the horizontal distance traveled, we need to know what is the constant horizontal velocity. So we need to know that. What we don't know the constant horizontal velocity, we only know it as that resultant velocity. Okay, then in order to be able to do that, we have to use the formula V equals d over t. So we also need to know the time it takes to travel that whole distance. So at the moment, we know none of these things. Okay, so the first thing you do is, first of all, find out what is the horizontal component of the velocity. So the horizontal component of the velocity is, the way we do this is the horizontal component is we resolve that red into two components. So that's the horizontal component, that's the vertical component. The horizontal component, this is adjacent, that's hypotenuse. Here's your right angle. So we are going to use 14 cos 30 and then we're going to put it into our calculators. And then here we go. 14 cos 30 is 12.12. Okay, so I've got 12.12 meters per second. I'm just going to write it here. So I've got, because I might have to rub the board a bit later. Okay, so we at least got one thing. Now we need to get the time. Now it's hard to find the time for the whole thing, but there's a secret here. If you find the time it takes to go from the bottom to the top, and then if you multiply that by 2, then we know the total time. Now, in order to find the time taken to go from the bottom to the top, we are talking vertical. Okay? So what are we trying to find out? We're trying to find out the time it takes to go from the bottom to the top, because we know that the speed, the vertical speed at the top is 0. So that's let's divide this whole thing into 2. Okay, so we're dividing this whole parabola into 2 halves. We're only going to look at 1 half now. So the vertical velocity at the top, I'm just going to rub this out. Okay, so you got that information there. The velocity at the top, Vf, is 0. We do not know Vi, but it's possible to get Vi by getting the vertical component of the velocity. So the vertical component of the velocity, this is your opposite, that's your hypotenuse. So you're looking at 14 sine 30, and your 14 sine 30 is 7. Okay, so I'm just going to write 7 meters per second. So this is 7 meters per second. So that's what I've got. So we know those two. Okay, then there's that hidden secret thing. Remember in these questions? So that is always the velocity at the vertical velocity at the top is 0. And the other one that we know is that the acceleration due to gravity is downwards and it's 9.8 meters per second squared. So this is negative 9.8 meters per second squared. So now we know 3 things. We have to find the 4th. So who's going to come to our rescue? the kinematic equations, okay? And the one that's going to fit here, this is to find the time. So we can use Vf equals Vi plus At. What are we trying to find? T, okay? So Vf, that's the velocity at the top there, is 0, is equal to Vi, we just found that was 7, plus negative 9.8 times T, or your T becomes 7 divided by 9.8, you get 0 point something. 7 divided by 9.8 gives me 0.71 seconds. Okay, so the time to go halfway is 0.71 seconds. So my total time that it takes to go the whole distance is 2 times 0.71. And 2 times 0.71, so multiply that by 2 and I get 1.43. Okay, so that's 1.43 seconds. So where am I going to write that time? Over here. So the time taken to go the whole journey is 1.343 seconds. So now the rest of it is now just a piece of cake, just a little bit left. So now we know we're trying to find out D. Now we know two of those things. And the equation that we use is V equals D over T, or D is V times T, or the range or the distance traveled is our velocity is 12.12. So we never mix up horizontal and vertical components. So we keep the horizontal separate, and the total time is 1.43 seconds. So now 1.43 times 12.12 is 17.3 meters. So you always in your calculations use unrounded numbers, and then your final answer should be given to the least number of significant figures in the question. So it should be to 2 significant figures. So I can write my final answer as 17 meters, but always show the unrounded number first, okay? So I hope that made sense. So the key thing to remember is when you're given very little detail in a question, but there are these hidden quantities, step 1, find both the horizontal and vertical components. Step 2, use the kinematic equations to find the time it takes to reach the highest point, because the velocity at the top there, your vertical velocity is 0, horizontal velocity is still there. You use your kinematic equations, find T, then you multiply that T by 2 to get total time, and then you just use V equals D over T, and voila, you have your answer. So I hope that made sense, and bye for now.